Today we're going to be looking at function transformations. So we're going to consider a function f of x equals 4x cubed minus 2x plus 2. So this function is a member of the cubic family. And its parent function is going to be, we could say f of x equals x cubed, or we could say y equals x cubed. So this is a polynomial function that belongs to the cubic family. So we're going to make a table for this function, and remember Desmos actually does that really nicely for us. So if we open Desmos and type our function in, you can put the f of x in or you can leave it off, it doesn't actually matter. We have 4x cubed minus 2x plus 2. If we click the gear icon and then this little table, it will make a table for us, and let's make it like ours. So -3 is going to be -100, -1 is 0, 0 is 2, and we're looking for 3, 104, 5, 492, and lastly 8, 2034. Okay, so there's our table. We could also just plug these values in to get our table if we don't want to use Desmos. So now what we're going to do is manipulate this function. So the first thing we're going to do is we're going to find 2 f of x. And so that notation might look scary, but really f of x is just y, so 2 f of x is just really the same thing as saying 2y. But let's look at what it looks like with our function. So you remember f of x is 4x cubed minus 2x plus 2. So if we have 2 f of x, then that's just really 2 times our whole function, 4x cubed minus 2x plus 2, right? Because that's our f of x. And so we can actually find this. All we have to do is distribute in that 2 goes to each of our terms, and we get 8x cubed minus 4x plus 4. So this is 2 f of x. So let's make a table, and we're going to compare it to our original one. So let's use Desmos again. So our new function is 8x cubed minus 4x plus 4. And so we can see the difference between our two graphs in Desmos. Let's make a table for this guy. All right. Oh. Click out. So we're going to put back in our same value. So we want -3, and this time we've got -200. It's still 0 at -1, 4 at 0. Then we want 3, 208, 5, 984, and 8 is at 4068. So let's look between these two. So what do we see? So our x values are the exact same. They haven't changed at all, right? We sort of built it that way. For -3, instead of 100, we now have, or -100, we now have -200. If we look at -1, we still have 0. At 0, we have 4 now instead of 2. At 3, we have 208 instead of 104. So the question is, how is this value related to this value? So if our original value was -100, and then we multiply our function by 2, we get -200, we just multiply that value by 2. We see that again, 0 times 2 is just 0, so it doesn't change. 2 times 2 is 4, 104 times 2 is 208, etc. So when we multiplied by 2, right, to f of x, we just see our y value also get multiplied by 2. And that makes sense because remember we said that 2f of x was just 2 times y. So the y is multiplied by 2, or we think we can sort of describe that as a stretch in the y direction by a factor of 2. So let's look at a different one. What if, instead of multiplying, we add? So let's bring our function back so that we have our original table on the right. And so this time, we're going to add 3. And so we can do the same thing we did before and write that out. So f of x, if you remember, was 4x squared minus, 4x cubed minus 2x plus 2, right? That's our original function, 4x cubed minus 2x plus 2. And so if we take f of x and we add 3, then we're just going to take f of x, which is 4x cubed, minus 2x plus 2, and add 3. And so our new function is 4x cubed minus 2x plus 5. So I want you to take a second and think of what do you think we're going to see if we just add 3? What's going to change? So remember, these were our original values. What do you think we're going to see in our new function values? So let's write out our new function. So we have 4x cubed minus 2x plus 5. So we can make a table again. Let's put in our values. So we want -3, -1, and 0. So we get -97, 3, 5. Now let's put in our other values. We want 3, 5, and 8. So for 3 we got 107. For 5 we got 495. And for 8 we got 2037. And so if we look, what's the connection? We have -97 and -100. So our new value is 3 more. So we have 0 and 3, same relationship. 2 and 5, 104 and 107, etc. So we see that the y value just gets +3. That makes sense? F of x is exactly the same thing as y. So we just see a shift up in y by 3. And so let's go back. If we look at these functions, notice we have the exact same shape. It's literally just been moved up 3. Let's bring back our other function. So we had 8x cubed minus 4x plus 4. So this was our other one. And so let's talk about how these are different. Let's zoom in. So if you notice, if we look at the black one, that's definitely, there's more space between sort of this minimum and this maximum than there was in our original function, right? More space because they're further, they've been stretched further apart. So that's how we see that stretch in this graph. Whereas we don't see that same stretch between the red and the blue graphs. They're about the same distance apart, the same length between that max and min. Because it hasn't been stretched at all, it's only been moved. And so we're seeing that vertical stretch between those 2 points. And so let's look at, in general, what's happening. So if we multiply our function by a constant, I want you to notice something. This is outside of the parentheses, and what I mean is it's not inside here, right? So we're multiplying the whole function by a value. What this causes is a vertical, we'll call it dilation. That's just a way of us saying that it's either going to stretch or it's going to shrink. But it's going to do it specifically in the vertical up-down direction. It can also do one more thing, which we sort of already talked about. It can also be a vertical flip. That happens when we change the sign. So that's a negative a. So when do we stretch and when do we shrink? Well, we get a stretch when our a value is greater than 1. Really, we want to talk about the absolute value. We're not interested in the sign there. And we get a shrink when it's less than 1. So let's go back here. And I'm going to show you a cool feature of Desmos. So let's get rid of everything except our original function. So in Desmos, I can actually use f of x now that I've named my function, and I can just type in 2f of x. And now we see that stretch. Now, you might also make the argument it moved up. Well, what's happening here is that we're stretching, but we're stretching almost like the origin is our center point. So if you think about Play-Doh, if you put 2 dots on Play-Doh and you stretched it, if you use like ink, those dots are going to stretch too. So they are going to move. We're going to see our y-intercept move as well. Notice our x-intercept didn't move though. That's because that x-axis is sort of like our base point. It's like the center point of our stretch. And so if I change, let's do another one. Actually, let's change this color. If we do like 1/3 f of x, then we see that it shrunk, right? And you can really see if we look at this max min, those are much closer together than they were in our original function. So we're seeing that squish, right? We're getting a vertical squish now, or a vertical shrink, okay? So if we want to write that a little bit differently, if the absolute value of that number is greater than 1, we get a vertical stretch. The absolute value of that a is less than 1, we get a vertical shrink. And if that a is less than 0, that means negative, then we're going to get a vertical flip. And this flips over the x-axis. Remember, vertical is up, down. So if we're flipping up, down, we are flipping over the x-axis. So what about if we add a number? So let's do the same thing, except we're going to take these coefficients off, and this time we're just going to add a number. Now again, notice that this is outside. It's not inside that parentheses. It's sort of outside our function. And so if we just add 8, our function just moves up 8. If we subtract 3, it moves down 3. And so all this does is move us up and down, or is a what we call vertical shift. If our k is positive or greater than 0, then it's a vertical shift up. And we just move exactly k units. And so if k is negative or less than 0, then it's a vertical shift down. And again, we just go down k units. And so sometimes when we're talking about stretch, just go back really quickly, we might say by a factor of blank. Okay? So take a second, pause this video, and try these 3 problems on your own. See if you can describe how they've been transformed by taking the function f of x to g of x. So basically we want to rewrite g of x in terms of f of x. So pause this video, try that, and then come back. All right, so let's look at these problems. So if f of x is x squared, then we need to sort of identify what is in g of x that's not in f of x. And so that's this coefficient. And that's the only thing. So this whole block is just f of x. So that means that g of x is equal to -1/2 f of x. And so the question is, what does that do to our function? Well, it's going to do two things. So this is our a value. So absolute value of a is less than 1, and a itself is negative. Because it's negative, that means we have a vertical flip, or a flip over the x-axis. If our a is less than 1, this absolute value, so that's just the 1/2 part. So we have our negative and then our 1/2. That means we have a vertical shrink. And so sometimes you might see them say a vertical shrink of 2 because we're going to divide everything by 2, or sometimes you might see a vertical shrink by a factor of 1/2. It sort of depends on how you talk about it, what you say, but you can just say 1/2. So the important part is we have a vertical shrink and a vertical flip. So those are two things happening here. Let's look at our next one. So same thing. What is the difference between f of x and g of x? Well, if f of x is the root of x minus 2, that's where f of x is, and we have this additional plus 4. So that means that g of x is the same thing as f of x plus 4. So we have this number outside of our f of x. This is our k value, and this k is greater than 0. It's positive. So that means we have a vertical shift up 4. That's the only thing that's happened to go from f of x to g of x. And so if we graph that, we can also see that in Desmos. So let's throw those up there. So we have the square root of x minus 2. Let's go ahead and call this f of x, f of x. If we put g of x, oops, I forgot my x, as the square root of x minus 2, and then you've got an arrow out, so you can do plus 4 on the outside. We see that we just moved up 4. We can even check that by doing f of x plus 4, and we see that that is directly on top of that g of x function, which means they are the same. So let's do that again. We're going to do a similar thing with this next one. So let's put it in. We've got f of x equals x cubed minus 1. Then we have g of x. G of x is equal to negative 2x cubed minus 3. So we see we've got two sort of very different functions. And so you might see that we have to have flipped because the up side of our function is on the wrong side of the graph. So let's sort of think through this one. So this one we can't as easily just highlight all of f of x and g of x. But I do see this cubed. Over here it has no coefficient, and here it has negative 2. So we've probably multiplied f of x by negative 2. So let's go ahead and figure out what negative 2 f of x would be. So it's going to be negative 2 times x cubed minus 1. Remember, it's got to go in parentheses. Then we got to distribute. And so this is actually negative 2x cubed plus 2. And so if we're here, now the only difference is this is a plus 2 and this is minus 3. So how do we make positive 2 negative 3? Well, we would have to subtract 5. So we're going to take negative 2 f of x, which we already found, and we're going to subtract 5 from this now. So negative 2 f of x was negative 2x cubed plus 2. So this we got from this line. And then we got to subtract 5. So we're going to subtract 5. When we simplify, we get negative 2x cubed minus 3. So that should tell us that g of x is negative 2 f of x minus 5. And so let's try it. Let's type this in. So negative 2 f of x minus 5. And you can see When we do that, it lines up right on top of that blue function. So that's our g. And so we've got to be careful because it might be tempting to say that we are just multiplying by -2 and then subtracting 3, but that's not actually what's happening because our original function already had this -1. Things get a little bit more complicated. So what's happening is once we get here, our a is less than 0 and our absolute value is greater than 1. And then we have a k value, right, which is negative, specifically -5. So we have a flip vertically, or you could just say a flip over the x-axis. We have a vertical stretch by 2, and we have a vertical shift down 5.